So I'm joined by two fantastic speakers today. James Walker as our CEO and co-founder, and Hugh Price as our chairman and co-founder as well. James, that'd be fantastic for a little introduction, if that's okay.
Yeah, thanks, Ben. Hello, everyone. Yeah, so James Walker, I guess I've spent the past kind of decade or so helping enterprises with productivity across software delivery, and that's across test data and also software quality as well.
Brilliant. Thanks, James. And Hugh.
Hi, everyone. Hugh Price here. Yeah, I've been around slightly longer than James. In the wonderful world of test data primarily. Never thought it would be this long. But yeah, the problems have become, it's the same core problem, but it's become a lot more interesting now, as we say. So I think it's a good time to discuss about the new era of test data, really, in terms of some of the thinking we're doing, some of the technology that we're building, and, and obviously kind of the new thinking and the new approaches that people are going to have to deal with at the moment.
Fantastic. All right, look, let's get straight into it. So I think just setting the scene a little bit, to sort of follow on from Hugh there, we see that 80% of software projects fail. It's a huge number. It's a crazy statistic when you think about it. And there's all sorts of different reasons that happens for. We sort of feel, I think one of our strongest sort of senses in the industry, a lot of people see a lot of symptoms of problems, but actually understanding the real root cause for where these symptoms comes from is often, they're not necessarily the same things. If inside your organization, you see these sorts of symptoms, you have sort of, a lot of firefighting, a lot of technical debt, a lot of defects making its way into production, understanding ultimately where those things come from, we think is obviously super important. It's the case of sometimes you don't know where you're going if you don't know where you've come from. And a lot of these come from the problems with misalignment between what we'd refer to as the inner and the outer loop. You've got a portion of your enterprise world that over the last 20, 30, 40 years has had a ton of investment and focus. There's this sort of story around every company is a software company now, right? And if you think of the rises of different types of technology that have been able to support that from some, from IntelliSense code sort of completion all the way through now to generative AI and the rest of it, it's been seen as a real focus for a lot from, I'd say, most organizations, right? Most large financials now got huge software development teams and are really sort of trying to push the customer experiences that they can sort of provide. But on the sort of opposite side of that coin, or sort of piece there is that, the outer loop, that all the supporting items are typically neglected. And so that sort of misalignment in terms of requirements, in terms of testing, in terms of data, in terms of the environments people are using, in terms of maintaining sort of all the details that are required to make those things, to make that inner loop really efficient and really sort of push out value, slows you down. And then actually we would see that as the real sort of cause here of a lot of the problems that organizations are seeing. So this is some of the core problems we want to talk about. We want to sort of show why we think that there's a different way to approach a lot of these, and ultimately a different way to sort of think about how you're working with your enterprise test data, and why it's such a sort of fundamental piece of this. Ultimately, we see the Curiosity platform as sort of an outer loop platform. We're really trying to support all of those areas so that actually you can go from an idea through some very complex requirements, tests, data, environment processes, with all of the associated complexities that they may have, right? From understanding requirements to building the right tests to make sure there's the right data there, to having environments sort of in a position to be able to be spun up, spun down, so on and so forth, and then maintaining all of that. Like, it is a cycle, it is a circle that will kind of repeat. And the better you are at doing that, the more that you'll get out of your inner loop and develop the productivity and the things you can actually go and do. So actually those symptoms will start to be sort of solved or moved away from, because actually you're now providing clearer requirements. You're sort of removing bottlenecks to your test teams and your testers, and that actually you're really able to sort of hit your business goals depending on what you're in and what you're doing, from very sort of simple things to very complex things, because actually you understand what's going to be delivered, how it's going to be delivered, and all of the elements that are sort of associated to that. So that's why we're here. This is what we want to talk about. And, I'm going to hand over to James, who's going to talk about data. He's going to talk about some of these elements before we get into Hugh talking and then showing some of these pieces. So James, I'll pass it on to you.
Yeah, thanks, Ben. It's interesting looking at those slides you've just gone through there, I think what we're seeing in a lot of organizations is there's so much pain as they're going through their software delivery. And I think, really what we're looking at here with the inner outer loop is a way of kind of diagnosing that pain. Two of the biggest problems we see is data and software quality. And if you don't get those two things right, it causes havoc in your organization. Your sprints become slower, productivity gets hampered, software quality worsens, release on release. There's so much buggy software going out in the world, right? So I think it's very interesting just to look at these value outcomes and what can be achieved. So as Ben said, I'm going to talk a little bit about data for a while, and then I'm going to hand back over to Hugh and Ben, who are going to get into some, real world examples. But data is the lifeblood of every industry. That's quite a bold statement, isn't it? But I think it's very much the reality of the world we live in today, right? Data drives most organizations. It drives most decisions in the world. And if you think about that, data is just so valuable, right? It's driving operational efficiencies. Most process improvement within enterprises is based off of the data that's been collected in that organization, right? Most innovation is data driven. Look at AI and all the data-driven algorithms that are being produced on a day-to-day basis. Most strategic decision-making in an organization is based off data. Business intelligence is such a huge area. So I think data is really, really important. And I think hopefully you're going to see, some of the ways we can address and help with data in this webinar today. There's a bit of a quote here. So with data's immense value comes critical responsibilities, right? Firstly, we have to protect data. I think it's a really hard reality that, most teams that we talk to and we see, are still using production data in lower and less secure environments. And that's such a deep shame. We're in 2024 and that's still the reality of most organizations. Breaches are way too commonplace. Every year you see it in the news, there's at least 3 or 4 big data breaches that end up making the news and cause huge disruption. And that can really have devastating effects. It can have financial consequences if you're caught out by these regulations, but also it can have huge reputational consequences, which is even harder to measure. The second one here is data access, and this is kind of a hidden cost. And we see this in so many enterprises. And as Ben was talking about productivity, that's really the core indicator that gets hit when data is not accessible, right? And what we mean by this is most teams do not have access to the data they need, and this leads to productivity issues. It leads to quality issues. If you don't have data available, your team is going to go out and either wait for that data to become available by someone who's creating it. They're either going to spend their own precious time putting it together, which is, a productivity symptom, or if you don't have data, you can't develop and you can't test against it. And that leads to poor quality, right? Because all of a sudden we can't test the scenarios we need to ensure we have quality in the deliverable, in the software that we're producing, right? So data is so valuable. There's hidden costs here. There's explicit ones like data protection issues, but the hidden ones, productivity and quality, that has huge impacts on a lot of organizations. Okay. Now, the data landscape today is incredibly challenging. Hugh mentioned at the beginning, he's been in the data industry for far too long. Hugh's always telling me about the early days of data, mainframe systems, copybooks, etc. When I joined into the world of data, everything was very much relational databases, right? Your SQLs, your Postgres's, all your relational data stores, right? The internet kind of became a huge thing. APIs, obviously massive. Through the advent of that, we saw lots of different kind of data transmission types being developed, right? So XML, JSON, these NoSQL data stores have become very big. I think most recently what we're seeing is obviously cloud environments, SaaS, being a huge deal, right? And I think if you look at those environments, really there's no concept of kind of a back-end database, right? APIs are the primary gateway where we're accessing the data. We're interacting with our application. A lot of the time it's a black box. We have no idea what data is sat behind that, how it's being stored, and in what databases it's being captured in and stored in, right? And I think the big ticket one now, which is kind of on everyone's agenda, everyone's talking about it, it's AI, right? And the big challenge we're seeing with AI is a struggle from organizations to be able to adopt it. And they're struggling to adopt it because it's really hard to get all the data you need for AI in one place. It's really hard to make it available. It's really hard to protect it at the same time. And the challenge we also have here is, it's not just an organization is in one place now. Often organizations have a little bit of everything, right? An organization's been around 30, 40 years. There's going to be legacy in there, right? So we're going to have a bit of mainframe. We're going to have a bit of cloud. We're going to have, some APIs involved as well. It's very rare that everything is greenfield and we're on the latest and greatest technology. And the challenge we have is that is such a headache for anyone looking to implement the test data practice. You're not just thinking about XML and JSON messages. You've got to think about this entire data landscape that exists. So coming back to Ben's point about these inner outer loops he was talking about at the beginning, when test data and data is a bottleneck, really it causes problems across the entire organization. Okay. Teams suffer, developers suffer, business analysts suffer, testers suffer, everyone in that team suffers. The first suffering point is productivity. Developers have to spend time waiting for data. Testers have to spend time putting data together to be able to test the scenarios they want. Or if they do not have the data there, they have to go out and you can't test against the scenarios that you want to, right? Which ultimately impacts software quality. The goal of this webinar is to really showcase, the requirements of the new world we're seeing. And really, we're going to be covering how we see the vision of the new era of test data. So we're going to be going through 6 requirements. The 3 I want to call out, which I'm really, really excited about, that we're going to be showcasing in this webinar today, is firstly, navigating data complexity across systems. I said at the beginning, there's so many different data sources out there now, right? And the reality of systems today is it's very dispersed. If you want to go and create data, you're not just creating it into one system. You've got a whole lineage of different applications, different columns that are all connected together in this kind of spider's web, right? And if you're going to go out and implement test data and create data effectively, you have to be thinking about all these different data sources, how they're connected together, how data flows between them, right? The second one is visual modeling. What we're seeing in a lot of organizations is, some organizations will have a data practice, but commonly, unless you're using some kind of technique like visual modeling, your data coverage is going to be incredibly low, right? And if you want to be able to develop and test effectively, you need to have a really wide array of data available. And that's what we mean by data coverage. And visual modeling is a way for you to draw out all of these different data scenarios, align them with your requirements you have for test data. And it allows your teams to create rich sets of data they can move forward to develop and test with. And then the third one, which is my favorite topic, is AI. So we've been spending a lot of time experimenting with AI, but we've also built out a ton of functionality which adds value to test data, where you can come and you apply AI accelerators for understanding and building your data routines. So I'm going to hand over to Hugh and Ben, who are going to carry on the conversation. Excited, guys, to stop presenting.
Fantastic. Yeah. Hugh, you're first up if you want to share your screen.
Sure. Make sure you can see my screen. Wow. Okay. Can you see that? Can you see that screen? Excuse me. Give me a shout if there's any hassle. Okay. So I'm going to bang through these slides quickly, and then I'm going to head into kind of demos and just kind of show you around the product. This slide is basically, you can get a copy of the slides if you want. I kind of like this slide. It sort of does outline, getting your test approach right, your development approach right. But the slide I really want to talk about is kind of this one, this idea of understanding the integration points between systems. We talk a lot about, the mainframe was kind of, basically a 2-tier system, but life was simple. Now we've got so much stuff moving around, whether they're kind of Kafka messages, whether they're direct APIs, whether they're database calls, etc. And I think really the way to think about using data is to in effect understand each one of these interfaces. This term sort of blast radius, if you test this blue one here and you test that absolutely thoroughly, and that's both negative and positive. Negative tends to be completely forgotten. But if you actually have a ton of bad data testing, in other words, you throw lots of bad data at it and test in a very systematic way, make sure that no bad data can actually get into that system, then in effect you're sort of protecting the other issues. What most people try to do is kind of do quite complex integration testing, and they'll get a bug over here, but it's actually something that's happened here. So if you think about initially testing this more rigorously, then maybe moving in with this connection here when you're moving out to a more detailed integration test, and then you're gradually moving along. So if you start thinking about these as points of communication and data, because it is data, it's a transform as you're moving the data in and out of the system. But that is really a good way to think about it, and to actually then maybe just draw it all up on your big whiteboard, and then just sit there and say, well, how do we make this better? How do we make this better? So I think that is really kind of a lot of the stuff that we do. A lot of it is to do with kind of the building of the models of what these should be. And I think we're going to have a couple of demos on that later. Now, I'm going to get into a little bit of, these are a few of the problem statements, data complexity across systems. I think everyone understands that now. I mean, you're lucky if you get away with 500 systems in your organization. It's probably more, many more in some of the larger Fortune 1000 companies. And what you really got to think about is how do we build those kind of the testing of those integration points, the testing of 2 or 3 joined up systems. And the other thing to really think about is to actually start using virtualization in a much more intelligent way. There's been virtualization tools around for ages, but I've never really seen people do a very clever job of actually having the right endpoint responding in the right way. And I'll show you a quick demo of that as well. So that's the first thing to kind of think about. Next thing then is, we're moving now to very much this kind of API landscape. Everyone's got APIs. APIs change as well, and people really don't understand if a new version of an API is coming out, how does that affect the system? So you have no idea are actually using your API, etc. So there's the understanding of the APIs, and the understanding, again, an API is basically a payload going in and a payload coming out. You should be able to create a virtual version of it so that people can test against it. You should be able to build lots of bad data to test it, and then you should also be able to put data in and understand what's going to happen to that data as it transforms out into the rest of your system. There's a lot of Postman. People use Postman, and it's very much one at a time. But what we're doing at the moment is building lots and lots of lovely juicy variations of that within the tool. Carrying on, platform extensibility. There is so much change going on. You need to have a platform. Our product's called Curiosity Enterprise Test Data, and within that we have the ability to add in, your APIs, any kind of new technology relatively quickly into the product, so that you're not hanging about. We're anything from sort of 10 minutes up to possibly a week for more complex integration. So you need something that's going to be able to extend, because change is the new world order, I guess. So, okay, that's basically on the end slide. So I'm just going to take you through through some of the plumbing. If you guys haven't seen our tool, just kind of understand, some of the thinking behind it. Now, what we've done is we've got lots and lots of really cool, very specific utilities, which allow you to do all sorts of things: scanning the data, validating the database data, generating data, comparing data, subsetting, cloning, finding, and all sorts of different things. And this list is growing all the time in terms of what we get up to. Now, sitting beneath them is really what we call kind of these the definitions. And what we'll do is we'll scan the data. And actually, some of the work that James has been doing is this being able to, in effect, build up we call it sort of the curiosity catalog, which is a central place that all teams can go to. I was trying to create a specification in Jira the other day, which had describing all the data. And it was so much easier just to go into the tool here. There are some other tools around here, but we've worked quite hard on it, where it allows you to really actually go in, build up a catalog, track the versions, which includes all the versions of the data and the APIs, have all the details about the columns. And then what we can also do then is build out those relationships between them, or as we call them, soft relationships, business relationships. It's getting slightly better in terms of the amount of foreign keys in databases, this ability to understand how these tables and how these nodes are all joined up together is kind of important. One of the activities is this validate and scan the database. And we can probably get you to, if you're about 10% understanding, get you to about 50 to 60% within a few days in terms of building up these relationships. And we do that with using some machine learning technology to scan the data. The other types of things that we can also do, James talked about a little bit about, this idea of the density of data. We have a kind of slot diagram tool that one of the reasons for this is to kind of understand the differences between environments. People very much rely on production data. I don't know how many, should we say, fervent discussions I've had about just using production data, whereas actually all of your development environments should have much richer sets of data. And what we can do is compare them up and look for the differences. And what you're really looking for is for this spot diagram, depending on the dimensionality, to be rich as possible with a combination. Okay, so that's kind of some of the core plumbing. Now, when we get into message payload, what we've done here, these lots of the stuff to do with, open banking, all the various things. There are just tons and tons of these message structures. And we spent a lot of time actually working on scanning, bringing in these payloads, bringing in, Avro files or whatever, being able to break them down into their core components, which then allows us to, first of all, scan them to understand what's in them, and then also then be able to generate the data that's pushed out into them. I think Ben's going to show you some model data where we look at actually building out much richer sets of kind of message data. And again, think of that almost as payload data. Now, I'm going to start with something which is probably a little bit basic, but actually, if you think about what most people do as developers and testers and business analysts and trainers, is they spend an awful lot of time looking for data. Okay, so and that generally doesn't change. A lot of it is done, by casting queries or running some reports and hunting around. But we've got a very systematic approach to being able to come in and say, well, I need to go and find some data. Let's go and have a look at data. 124. Yeah, so I need 124, credit limit of 124. The test case I'm going to use is a specific credit limit. So I need to make sure for my test that I can test that. What I also want to be able to do is I'm going to transact against it. So I'm going to assign a unique lock on it. So that allows us to create a place within your organization where people can go find data in a structured way. Now, if they can't find it, we will make it for you. And what we're doing here is this is running one of our pipelines, and you will see here that it's running the find. It will then come along and not found true. Now what's it going to go and do and say, well, I didn't find anything with that particular credit limit. And now what I'm going to do is just go and, in effect, generate some data with that parameter because we've mapped that parameter into our generators. And then our generators come in, and at the end of it, we found some data. So it's a very structured and organized way. There's a lot of plumbing behind that, look at maybe in some of our videos. So that's one example. I'm just going to take you through 4 kind of typical examples of the types of things. I would say finding is probably about 50% of our customers. That's what they'd like to get under control first. If you think about it, people finding things tend to think of that as a scenario. I'm looking for a specific scenario, which is what I was doing there. The better way then is once you've got that up and running is to think about maybe modeling those variations out. Now, in this one, what I'm going to do for this one, this is an interesting one. We talk about coverage. Now, so this one here, what I'm actually going to do is I'm going to go and I'm going to pull data from the target system, and it's basically a bunch of the transaction codes. It could be payment codes, it could be all the different variations that exist within it. And then what I'm going to do is I'm going to generate a richer set of data, and a few values to be able to do that. Now, what's happening here is that we're actually we don't just use modeling. There are certain times when it's a negative testing, you might want to use what we call a constrained combinatorial technique. And in effect, what we're doing here is and this would dynamically create a set of data based upon the system under test. So we would attach it to the system, look at all your codes. We did a really simple one the other day just to make sure that every drop down for every state, the US state, actually had a value in it. So for that one, all we had to do was just include the US state, and that then just generated that data. Let's go and have a look at a previous one. What you can then do is go and have a look and see. I'll just quickly show you that job. Go job. See this. What we've done here is that we've actually gone off looked at a couple of different values in our target system, and we've blown them up to make sure that we have all the various different reference codes and order statuses incorporated. The result of that is that we've then actually generated 140 different customers and orders and items, each of those with those particular statuses. So coming back to our spot diagram, that means we've got a nice rich spot diagram because we've kind of worked on those variations. Next one now is actually just setting up environment. Now I'm going to fire this off, but I'll show you one that's run earlier on. So here what we're doing is we don't want full size database in our QA environment. So we chain together a few different things. The first one is we're going to create another QA environment. We're going to pull out just 3 suppliers. We have 100 suppliers. So we're just going to pick those. Just going to, and they get a refund. It's going to become a supplier. I'm going to fire that off. Now, what you'll see happening is we've chained together the validation. Now, validation, so if you remember, I created a bunch of soft keys plus other business relationships. If we look at one of the previous runs, this one, you'll see, let's just have a look at the job itself. So in our source system, which is actually a development system, there are tons of bad data in there. And that's inevitable. As developers are developing, they will leave, they'll have a failure and they'll leave some bad data in there. But what we've done is we've basically pulled out a subset of data. We've moved those in. We've supplemented it with some specific data that we're interested in for our environment. We've then populated our QA environment. We can do things like we've masked the data as well as we've moved it. You can also do things with dates. Maybe you want to move the dates forward to today. A very common problem is that with real-time systems, the dates need to move forward. And you can see at the end there are no errors found. So we've created a nice, clean environment. We also get into cloning. Cloning is really much easier than subsetting or moving vast amounts of data. Quite often, if you have a bug in production, what you want to do is pull out very specific, maybe account history, move that over, mask it, assign it a new set of primary keys and foreign keys, and push it in. And that is by far the most nimble way of being able to get data down. I mean, the amount of time that people will spend days and days trying to recreate a scenario in development. Now, this one here, we talk kind of about an integrated test. Now, in this one, what we're actually doing is we're playing around. This is actually a migration. And what I want to do is I want to create the same data in 2 environments. So one is in SQL Server, one is in, let's make it B- for the virtual response. And what I'm actually going to do now is I'm going to fire off, create some data in both environments. When it comes to migration testing, you kind of need to know that you're putting apples into both ends, even though those apples might look slightly different, different variations. But what you'll also see here is that we've actually come in, and as part of this, we want to create a virtual message. So we're mapping the data that we're creating into our virtual response. So if we go and have a look at that job, what you'll see then is that we've actually created a set of data into 2 separate technologies. We could have used an API, we could have done pretty much anything you want. And what we've done here is that we've actually populated, this is the request, which would go into whatever SOAP UI, whatever tool you're using. And then this here is the actual response. Now, we've pulled in the organization ID that we created. So that would map. But the other information, the B- has come through, all of this operating profit has come through from the data that we generated. So we've been able to very simply, by mapping the data into those messages, been able to go off and do that. Hopefully, I mean, it's a bit quick, obviously, but the idea here is just to kind of give you a quick show around some of the kind of fairly standard things that we do. A lot of this stuff takes no more than maybe a day and a half to set up for each one of these. And then they get exposed into our self-service portal, and users can just request them. They can request them through iframes. They can request them as part of their automation frameworks, whatever they want. Ben and James, back to you, I think.
Fantastic. Thanks, you. Taking the screen, you said?
Yep, good.
So this is a great chance, just whilst I bring up the slides, if there's any questions, feel free to put them in the chat. I see there's one from Andrea, I believe. We'll promise we won't forget that. We'll come back to it. I just want to show a few things. Firstly, we're just going to talk about sort of, I think, doubling down a little bit on what you've shown there around how we're using models and leveraging models around data. The visualization of models just gives us such an ability for collaboration, understanding. Whenever I'm in with prospects and customers and I see them interacting over a model, it's a much stronger conversation. It's incredible to how visual we are, right? As humans, to sort of look at something and very quickly pick up. And I think you see it from the pipelines that sort of shown there. You can look at those pipelines and very quickly sort of understand what's going on. I've got a job, I'm going to go and log some information. Depending what happens, where am I going to go next, right? So they're a really good way, especially when it comes to data, to starting to think differently about your data requirements, how actually essentially every requirement in many ways is a data requirement. We're going to talk a little bit about AI and what we're doing in terms of natural language, how people interact with our system, how you work out lots of complex things, and ultimately some nice ways to kind of go and leverage AI. And if I just build that out a little bit, really one of the goals is to be able to provide such an interaction that actually you can ask questions as you want. And over time, we are building up knowledge that is ultimately stored at the moment in lots of random places, people's brains, written down in a Confluence page somewhere, the rest of it. And over time, understanding what happens with that data, where it goes, who it interacts with, all of that sort of stuff, sort of disappears or gets harder to kind of go and maintain. So I'm going to show a few of those bits right now. I do think, just taking a little step back, I do think it's important to understand and sort of re-comment on a couple of bits from Hugh there. Production, most people, will have sort of a view that production is life, but in test and dev, you really want a much richer set of data, right? This is typically a world that people will sort of sit in scripts, right? So for injecting some records into this, it's quite a difficult thing to understand actually what's going on, how much data, why, is it good, bad, ugly? I think it's difficult, right? You'd have to have real SME knowledge to take this to the next level and to be able to do it at scale, to be able to let lots of people be able to interact with the system with the right sort of data. Same when it comes to messages or, XML, JSON, et cetera, you get a general sense of what's going on here. But in terms of what your system is using and how it's being used, it's difficult to get an understanding if you need one of these records or 1,000 of these records to be able to thoroughly test your application. So the first thing to sort of get into is really starting to structure some of those pieces. So we do that through data activities. And, if I take that SQL, which is essentially going and injecting some records, what I've done here is I've structured it, I've versioned it. So I can come in, I can understand the table structure. I can understand the type of data through tags that's being used, the descriptions on the tables. So if I'm new into an organization, there's quite a big cost of being able to up-level people to understand what that system is doing and why it's doing it. It's things like, understanding where your not just sensitive PII data is, but things like, actually, this is the bulk of our HR system, or this is the bulk of our financial system. This is where the majority of X and Y and X, Y, all of those different scenarios. And I'm doing quite a small system here. So when you start to multiply the complexity of those sort of current process, you need a way of being able to kind of go and do that and interact with a sort of structured way. What it then gives you is the ability to sort of understand, well, actually, what as part of this series of scripts and the rest of it is being generated. How from our side, we want to apply structured information in a flexible way. So this is a great start. It's a really strong way of being able to build rules that fit different sort of data points that you want, and so on and so forth. But actually, you want to kind of take that to the next level. I would say one level up from it is, as Hugh showed, around being able to prefer users' forms, right, to be able to interact. So they come in, change particular details, the amount of records, the amount of different types of accounts, where that data goes to, so that their interaction with sort of a modern test data platform can be in their sort of their language and their world, right? So you could embed this inside a Jira Confluence page, or, inside an environment that tester or developer is it totally fine. You are just giving them sort of a structured approach of being able to do it. But actually, really feel that the next sort of piece to be able to move this on is to start thinking about your data as a visual model. So as our modeling tool, this is, if you're familiar with sort of BPMN or Visio type, flow charting, it gives us tons of capabilities to be able to do that. In this sense, I think it's important just to understand that same activity from our sort of world, we can start to model. So what does that mean? It means that as I look to my different account types, I've got savings, I've got transactions, I've got transaction types, et cetera, it becomes easier to understand ultimately, and also easier to then start to discuss as a team. So I might be on here and having a conversation with James about, hey, this is what our current sort of process is when it comes to different accounts we've got, how much money we're putting through them, how we're doing those transfers, the type of customers that we need. And James can start to, essentially argue with me about it. You can say, well, actually, we don't just have savings accounts, we also have current accounts, right? And we need to sort of make sure we're testing for those as well. And so the data structures or the process starts to change, and that we are now modeling data, right? So I'll just put in a few different examples here, right? But it's important because to start with, I had some SQL scripts, right? A few SQL scripts that were doing something. I'm now being really efficient with the type of data that I'm working to, i.e. I've now got, in theory, 3 different data generations, 3 different ways of injecting data into my database. But I'm actually tying that back to a requirement that's being used. This could be a series of tests that we've modeled. This could be some automation. It could be an API. It could be essentially anything that you're trying to design to go and deliver. Fundamentally, you're looking at it from the perspective of data first, i.e. what data do I need to be able to go and support this requirement? What do I need to go and to be able to support this particular set of testing? And actually do it in the most efficient way. Whereas you compare that to sort of thinking of, I'm going to go and copy production and put that in and then start testing with production. Ultimately, you don't really know what's in there. And you're using a lot of infrastructure, a lot of environment, space and time and effort to get some data somewhere, because that's normally, the struggle. People just want something somewhere to be able to go and work with. But actually, if you start to take a little step back and approach the problem differently, to say, well, actually, I'm running 1,000 tests or 10,000 tests, whatever it might be. What do those 10,000 tests need? How can I model that in a way that actually I can push this data into my systems and then, progressively over time, build up a really nice repertoire to be able to sort of advance and take forwards. Hopefully that makes sense. I'm just going to switch into something that looks a little bit more advanced. So this is just a representation of an XML message. So this XML message, which I sort of briefly flicked up, what I've essentially done is we've just looked at one of the different tags and the structure that exists, imported that in, and just started to model. So actually we know the types of currency we want to work with, whether whereabouts in the world we are. Hugh being in New York, maybe he's more interested in the USD than me here in the UK after GBP. The type of transactions, the types of IBANs and BBANs and so on and so forth, right? Like it's a very straightforward way of being able to collaborate and interact with people, but with data at sort of the heart of it. So, instead of having some XML messages that I think are, stress testing my system, I'm able to look through all of the different combinations of this particular model, for example, and actually go and generate now 31 different messages that are going to give me the coverage of the things that we are trying to deliver, that we are actually trying to go and push, and that we are, as a team, as a release, whatever that sort of looks like for yourselves. It gives you provable way of being able to talk about what you're testing and why. It gives you all the data that's associated with that. And actually the maintenance side of things becomes very easy. So a new currency comes in play, you can add that currency, go and generate your new set of data. And you've got a version controlled requirement that's sort of provable, quotation marks, based on, all the knowledge that you and your teams are able to sort of pull together. There is obviously a requirement here, and people like to talk a lot at the moment about AI. Of course, I'm just going to look into our data dictionary. So Hugh's absolutely right. The data dictionary and our sort of curiosity catalog, so to speak, is designed to be that sort of central hub for storing lots of the different complex environments and different data that people are going and working with on day to day, and if you think about it, it's absolutely sort of the heart and soul of all things that you are doing as an organization, because to James' point, everything comes back to data, and there will be a level of complexity that sits there that's quite complex. That's quite hard to understand, especially if you're new, like maybe new to a project, or you haven't worked on a particular application for 5 years and all of that sort of stuff. Getting to grips with it is quite difficult, and you're often reliant on a lot of people. So this is where we're starting to introduce our sort of AI assistant. The assistant will do various things for us. So depending on how you want to interact, will essentially depend on what we can do. It's contextual. It's going to go and summarize. In this case, we've got this Curiosity Bank, which is a Postgres database, and it's going to go and look at this particular schema, and it's going to understand, okay, here's these tables are doing for you. This is reasonably well named: credit cards, customers, transactions, ATMs. You'll get a general sense of what's in there. But actually how they are logically represented, their foreign keys, their primary keys, any sort of soft keys that might exist. There are levels to how we can sort of leverage machine learning, as you sort of spoke about there, to be able to get more and more information into our AI. And then as part of that, what do we want to do next? Well, generally, as we sort of see here, there's not a ton of description, there's not a ton of stuff that's going on, but we can start to take that to kind of the next level. It's one of our developers said to us a while ago, when I first was sort of using the AI, all of these descriptions were filled out. He quite candidly said he was too lazy, so the AI did it for him. So I love that because it's like a small microcosm of humans, but it also shows that actually now it's done a task that is very valuable, but a lot of people struggle for time and all sorts of reasons to do, time, knowledge, etc., etc. It's tagged these tables for us, so it's gonna, it's going to show us where personal information is, it's going to show us where banking information is, so on and so forth. We can ask it, of course, questions, right? So excuse my typing, but as we say, give me SQL for the customer table, right? And of course, depending on your prompt, depending on how you ask, what you ask for, it's going to go and interact with that. And in this case, it might give me the DDL. If I'd be more specific, I could have asked for it to give me something to be able to go and insert some records. If you are new into an application and you're really trying to understand it, or if you've been there for a little while and something has crept into the system that you're not so familiar with, the AI is a really good way of being able to kind of go and do that. And in this case, it gives us that particular set of information. And then, of course, you just come in, run that query, right? So you can sort of understand, okay, what's going on. So it takes from not much knowledge, presumed on myself, to then being able to go and interact with the schema or a system in a really fast way. And there's lots of different sort of elements we are looking to here. Identifying keys it's potentially one of the most important ones. If we're going to go and put some data into a system, we want to understand what's impacted. Not just foreign keys, but we want to look at soft keys, right? We want to look at missing relationships. So things like this table looks pretty good. We've got potential that the ATM is missing something and so on and so forth. This is going to go and infer or change some of our decision making when it comes to how we sort of interact and work with the system. Final piece, which is I think more about sort of exploring as you start to learn before you get up to something that's a bit more robust in terms of repeatable jobs and pipelines, is just finding. Let's just go and find something. Let's be a bit more precise about it. Say, find me if I exist inside this database. So one of the core elements I think we've been talking to here is there's lots of different ways that teams need to be able to interact with their system. So some more structured, some with a level of being pragmatic about it in terms of forms and that sort of stuff. So in this case, it's given me that SQL, right? So I can just go and execute that. That's great. You could ask the AI to go and do that for me as well. You could ask it to return that customer ID. As you start to interact more and more, it's a really easy way of being able to now, if you think about what we're doing, interact with a complex database definition that potentially I don't know so much about. Pull in this case, a few records for myself, as I've been, injected myself apparently 4 times into this system. I don't know SQL. I don't know how to go and necessarily work with the database potentially. I'm leveraging business knowledge or business questions to be able to go and start a finding journey as we start to build up a kind of more robust platform. So that's what I've got. That's what I was going to show. If there's any questions, feel free to put them in the chat and me and the team will sort of talk through. It's a little bit of a Q&A now, but hopefully that will make sense. James, are there any questions in the chat?
Yeah, so there is one from Andrea, who has asked, does introducing API into the testing phase not change the system infrastructure that's being tested? Hugh, I don't know if you're about, do you want to pick that one up?
Well, the system infrastructure is simple system infrastructure. That's not going to change. I mean, the approach of testing the API more thoroughly would seem to be, I think most companies realize now that, screen to screen, but, if you can test that through Chrome, blah, 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 etc., you've got all the usual issues with all that sort of stuff. But if you've actually, you have tested that API to death, then, and firstly, understanding what it's supposed to be doing, and there's lots of little tricks you can do to do that, measuring the scanning the API inputs that are coming in, scanning the API outputs gives you a good picture of it. The next thing then is to actually say, well, what happens to that data once it goes through the API, and usually ends up somewhere else, and that mostly is inside some kind of database. And being able to scan that data to be able to look at what it is a massively much more structured way to be able to test your, multiple APIs. If you can do that in a very structured and organized way, you're also building up the documentation, which, as Ben was showing you, you could be just as easily doing that same type of interaction using AI against the API. If you've been through this process and if you adopt this approach, I think most, decent testing sort of practices will be testing those APIs extremely thoroughly. So hopefully that'll.
Yeah, agreed. I think there's questions. Interesting, just having a look through some of the poll in terms of how often people find their testing incomplete. Doesn't accurately sort of represent production scenarios.
Do you need to play that on the screen? Sorry, I can't see that.
I believe I can click show results. So I think it'll be showing to the audience at the moment. Hopefully, I'll talk through generally, right? But 20% almost always, right, in terms of incomplete or doesn't represent, the scenarios that they're looking for. 42% frequently. Basically, nobody has said never. So I think that sort of, is certainly in line with the things that we see. There are just a couple of questions. Could you share more on how data masking works with your tool? Do you have redefined masking rules, or can the rules be customized? James?
Yeah. Well, I'll do that one. Yeah, absolutely. So we've got an absolute vast array of masking rules. Lots of them use kind of homegrown lists, and then we hacking pick values out of lists. That's actually probably the most common method that people use. So we've got tons and tons and tons of them. Absolutely, in terms of customizing them, you'll come across your own particular format, the account, which are made up of all sorts of different things, and it's very easy to be able to set those up and add them into the masking rules. Yeah.
So just a couple more slides as we sort of come towards the end of this webinar. So we have got a survey. So one of the things we're really interested in at the moment is we're trying to understand how your industry is tackling your sort of challenges around the inner and the outer loop. So the survey's looking at, different roles within the outer loop in terms of their impact on software quality. We recognize there's no one size that sort of fits all, and every sort of team, organization, etc., does sort of operate in their own unique way. So we're looking for insights. We're looking for sort of typical practices and experiences within your organization. It should only take 5 minutes to complete. There's a link in the chat, and we'll sort of follow up alongside the recording and the slides for this. It helps us when it comes to the industry, make sure that we are sort of trying to fix some of the most important challenges that you are facing, making sure that, ultimately we're sort of maintaining and fixing problems that really matter. So it would be fantastic for people to fill that in, and we would really appreciate it. So you'll get that in follow up. The other thing is looking a little bit forwards, is that we've got our next webinar in November the 21st. James, you are back. You are sort of alongside Rich Jordan. We're going to be talking about sort of the surviving software delivery, which is going to be really interesting. I know Rich has got a ton to say on this topic. It will be very sort of, I'm going to say, thought leader, and trying to really understand essentially why a ton of problems that you face today, why do they exist, right? And so, James, you're going to be tackling our Rich. I don't know if you've got any comments on that one.
Yeah, I guess it just comes back to what we were talking about at the beginning of the webinar, really. So many organizations are struggling right now. To Hugh's point, there's such an array of different data sources that exist in organizations, which leads to all sorts of challenges. But then also on the software quality side, right? You look at the quality of releases being pushed out, they're incredibly poor. There's so many bugs going out. Teams are just drowning in several issues. And really what we're going to do in this webinar is about what are some techniques, what are some strategies to help organizations and enterprises really survive in this modern world of delivery, to keep up with the pace of change, maintain quality, maintain productivity, and really strive going forward into 2025.
Fantastic. Looking forward to it. Hopefully everybody can join us for that one. It's going to be a great session. And I would just like to say thank you very much. Thank you for your time and attendance. James, Hugh, thank you for your insights and demos. It was all fantastic. And
Pleasure.
Well, thank
See you next time. Cheers. Bye.
Thank you, everybody.